Some of you have probably already seen that my 5090 did go through the melting cable issue, and my daughter wanted to help out with the artwork for today's video, so fried. I don't know if that'll be the thumbnail or not, but there you go, she helped out. So in this video, I'm going to swap some components in the PC to try to avoid this issue in the future. I don't know if it'll be a perfect solution, but I want to talk about what I'm doing, which I think kind of mixes several of the ideas out there for how to make the best of what I think is a fundamentally flawed connector design. But hey, one of the issues here is that if I want a 5090, just that's what I got. I would say a short version of what I wish would happen with this situation is that NVIDIA wouldn't mandate that this connector be used. I think that if they want to leave this as an option, okay, fine. But I would like to see on the open market some competition available. If we had some 5090s with a whole bunch of traditional 8-pin connectors, let builders choose that if they prefer over having these connectors, and which, you know, might look more sleek in your build, but, you know, hey, mine melted. I think a bunch of other people's did too. I did ask NVIDIA for any sort of comment on the, you know, rates at which these are melting, if they're aware of anything, and they did not choose to reply to that question. Now, they did send a replacement 5090 Founders Edition for my previous review sample that had the issue, so I do now have a new one, and is there any difference on the connector? Not that I can see. Okay, so what am I gonna do differently to try to avoid this happening again? Well, when I posted my video, I got so many comments and emails suggesting what I did wrong or what to do in the future. Now, my use case is more extreme than a typical gamer because I do use this in my benchmarking system where I swap out GPUs on a pretty regular basis. So this connector was certainly getting, you know, swapped in and out more frequently than normal, but a robust connector design like the 8-pin connectors, I've never had any problems with. Now, also the 5090 draws a huge amount of current, so, you know, that's also a rough use case. But anyway, the point is, like, I have a rough workload, but I think that a well-designed connector should be able to handle it. That being said, some people suggested that the fact that I was using the dongle connector rather than just doing the direct connection with the 12-volt connector, you know, directly to the power supply was a problem. Now, when I've looked into this in the past, I've reported this on news videos, when people have surveyed a bunch of different power supply makers and GPU makers, etc., on should you be using the like included dongle with your GPU, or should you be connecting directly to the power supply using the cable that came with the power supply, there's been conflicting answers. So I don't think that there's a best practice in that regard that's been clearly established. Now, another thing is there have been a number of things that people have designed to try to minimize the chances of this happening. Now, a lot of people say that the issue can be caused, or at least exacerbated, by the cable not being fully seated, and it may be working its way out over time. So there are some connectors that use color that you can see if it's not fully seated on either end, so you can kind of see if it's wiggled out over time or that kind of thing, or see whether it's seated all the way, because that's definitely where a lot of the initial claims have been made as far as what's wrong with this connector, is just that if it isn't fully seated, you build up more electrical resistance, and so then you're more likely to have things get hot and melt. Makes complete sense to me. I'm not any sort of electrical expert by any means, but it makes complete sense to me that that could be a factor in at least some of what's going on here with these melting connectors. So I do think it's a good idea to switch over to a connector that has those colored pins, but we have seen people show some of those colored pins melted as well and claim that they were fully seated. So that doesn't seem to completely stop the problem from occurring. Now, other people suggested that like Thermal Grizzly has a solution that allows you to monitor the current going through the cable and things like that. And I was considering that as well. However, one of the emails that I received, and I want to be clear that this is not like a paid sponsorship, but one of the emails that I received in response to seeing that video where I said my cable melted was from Cooler Master, and they actually offered to send me this. and claim that their engineers are fully confident that this will protect GPUs from this issue. So I'm not going to say that I can confirm that they are completely correct, but I will say that this is at least interesting. For one thing, it does have that colored pins on the connector as one of the features going on here. But the more interesting feature, and I actually had seen this in Gamers Nexus's coverage of Computex, they actually took a look at this, and there was a demonstration showing how this works. So basically, they have what they call GPU Shield Intelligent Current Management, which says it automatically detects abnormal current, adjusts output in real time, and alerts users through LED indicators for safer, more stable power delivery. So the idea is that your 12-volt connector will show a green light near it if everything appears to be normal. However, it will start kind of flashing red, or maybe it's orange, but it'll start flashing an indicator if something's wrong. Now, I believe that the pins are rated at like 9 amps per pin, and then if you get past 15 amps, that's where you might suspect things to melt, things to be completely unsafe. That would be like a critical failure. So the idea here is if it detects, I think over 9 on a pin, you'll start getting a flashing indicator. And then it'll go red if it's critical, and I believe it can even just shut things down if things are detected to be critical. And like I said, they had a demonstration of that at Computex that Gamers Nexus took a look at. Anyway, that looks pretty interesting. Like I said, this is in my benchmark PC, so we'll be putting this through a pretty rigorous workload, but now we're gonna go ahead and actually switch this over. Just thought I'd show you guys, since I'm taking out the old power supply. I was looking at the 8-pin connectors that actually go into the power supply on the one that burned, and I don't see any sign of issues on like the power supply side of things on any of the connectors or anything. So I just thought, this is the first time I'm actually taking a look at that. So the power supply side of everything seems fine. It was definitely on the GPU side of things and the dongle thing where I was seeing the signs of melting. Anyway, get back to swapping out the power supply, which is one of my least favorite things to do in a PC build, by the way. All right, so I'll unbox the power supply that we're hoping solves the problem. Like I said, I did get this sent for free by Cooler Master, but I'm not taking any money or agreed to say anything, or it's not a paid promotion. I didn't even guarantee I would put it in the video. I just did, after looking into my options, think, you know what, this does sound like it could automatically stop the issue if it does what it's supposed to do, and also give me the monitoring light and all that. So seemed like a good option to go with. So that's what we're doing here. So it looks like on here, so if we plug in with the 12-volt cable that comes included, this is where we get the indicator light. Green if everything's good, blinking if things are not good, and then it should, I think, go red and I believe shut off if it goes over that 15 amps. So that's the plan here. And like I said, I think it does have the colors on the cables, which should give us some indicator, visual indication that things are plugged in firmly. And so my plan will be to use that connector directly to the power supply for cards that use this connector, and then I'll run one of my issues, one of the reasons why I used the 8 pins with the dongle on my previous build was because some GPUs I benchmark use this connector and others just use the 8-pin connectors. It was easiest in my case to just have the 8-pin connectors, and then the GPUs that needed it, I would just use the dongle connections. But here I think I'm going to switch over just using the 8 pins directly to the power supply on the GPUs that need that, and this directly there, and I'll just deal with having extra cables running in the case and whatnot. All right, now I get to do the fun part of actually redoing all the power supply stuff in the PC. I thought this might be interesting, so I'm going to swap in the new 5090. So again, both are review samples from NVIDIA. They're both the Founders Editions. This is the old one with the melted connector, and you can, I might have to show, pictures overlaying this. It can be hard to line it up for the camera, but this is that melted connector. There's a little bit of melting visible on the actual GPU side connector as well. So that's the melted version. And then the review sample that I'm being asked to send this back. They want to take a look at it, and who knows if they'll tell me if they have any findings or if they're just trying to get it get it out of the way and out of the news cycle. But anyway, so they did send out the new one, but as far as I can tell, there's no real difference between the two. Like, I don't think there's any reason to believe that this new one I've been sent has any sort of difference that would affect whether or not that would melt. But, and you know, they haven't mentioned there being any difference as well. Little dongle connectors come in this little box. So again, this is the new one. There's still no, like, you know, they're not doing like the colored thing to help you see if it's fully seated or anything like that. So it doesn't seem like they've changed anything noticeable about the design of the connectors or anything like that I can at least see from a visual inspection. Again, I am not really knowledgeable about electrical cables or anything. But anyway, there's the new one that we're going to swap in, and I'll send the old one back to NVIDIA, and I don't know if they'll tell me anything about their findings. My guess would be not. Okay, ignore the hammering, by the way. My wife's putting together some shelves. Anyway, so this is the colored connector there, so we should be able to seat that in here. And then you can see that there is no visible purple, so that should indicate a fully seated connector. So it shouldn't be user error if that's, you know, if you can see any purple, it might not be fully seated, but we don't see any purple. Hopefully we're good. One last thought on the power supply is I was just thinking, you know, the indicator light is back here kind of inside of the case. Now, at least in my case here with this, you know, grate here, I can see that the light's green. So I guess I should be able to see in normal use whether or not that's a blinking light or anything. But just on thoughts on the power supply design is that maybe that light should have been somewhere on the outside of the case. I don't know if that could have been arranged, because I would imagine that in certain case designs, you're not actually going to be able to see the color of the light. But anyway, hopefully this is the end of my melting connector saga on the 5090. It'll certainly be interesting to keep an eye on that light and see if it's ever blinking to indicate any kind of issues. But I think that's what I've got for you guys today. I'll let you know in the future if there's any additional drama, but ideally the connector doesn't have that bad of a fail rate. And also hopefully Cooler Master is correct and that this does kind of solve the problems. Hope you guys found the video useful and or interesting, and have an excellent day.